Hello everyone, this is Ivan. I'm glad to see you again, and today I would like to talk with you about flight management system. Flight management system, it is an important part of any avionics of any airplane. It is some kind of computer-based system which helps pilot a lot during the whole flight. Basically, it done three main purposes. First of all, navigation purpose, guidance, and performance. In navigation purpose, flight management system helps to manage different navigation equipment and of course communication equipment. Many navigation equipment uses radio frequencies because it is radio-based navigation equipment like distance measuring equipment, VOR, non-directional beacons, and in this case, flight management system includes a database of air navigation facility and air navigation charts, and of course all airports. And during the whole flight, FMS can detect airplane location and then tune automatically all navigation equipment on board. That's why pilot do not need to think about what frequency I need to tune, particularly now, and what distance I need to have, or how I can measure a particular angle, because all of that will be done by flight management system absolutely automatically. That's why flight management system helps a lot and it saves a lot of time. And pilots should guide airplane and do not spend much more time with tuning different equipment. Also quite important, nowadays many flight management system includes a receiver of GNSS because it is one of the primary function of any flight management system to detect exactly location of airplane. Many historical airplanes includes separate GNSS receiver, or basically it is not only GNSS, it is the GPS receiver. However, most modern airplane includes GNSS receivers which support multi-constellation approach that improve performance of positioning. That's why also many flight management system includes GNSS receiver inside of its body. That's why it helps to obtain coordinates of airplane directly inside of flight management system. And then flight management system use pre-coded flight plan inside of its internal memory with actual coordinates of airplane, and then try to estimate deviation from pre-planned trajectory. Also, FMS generates an image for different displays in cockpit, which can help pilot to understand location in space and helps with navigation. In performance assessment, inside of most FMS, we have mass model of airplane, and if a pilot can enter some input data, as for example payload, mass, maybe quantity of fuel or something else, then flight management system can estimate many parameters that can help to understand if For example, fuel will be enough to fly. If this payload will be okay. That's why flight management system helps to estimate the best performance from the airplane value. In case of guidance, due to known flight plan and known current position of airplane, we can estimate deviation, and we can send all of that to the autopilot. Also, some airplanes has FMS with built-in autopilot. However, it is not a good approach, because autopilot requires to know much more about particular airplane structure to perform airplane guidance. That's why usually autopilot is a different subsystem on board of airplane. And today I would like to introduce one of the historical flight management system developed by Honeywell, GNS-XLS. This flight management system includes GNSS receiver on board, and helps a lot, and is installed on board of many small airplanes. Okay, first of all, let me show flight management system and how it looks like. I will use just a second Honeywell GNS-XLS training software to show you the basic principle of coding of this flight management system. Therefore, this is flight management system. Then I will need also electronic attitude and direction indicator and electronic horizontal situation indicator. Just to show how our coded flight plan will be operated during the flight. Okay. And I think we can start. That's why I just switch on my Honeywell GNS-XLS, and during the pressing button on, it will be switched on and initiated self-test. In this case, FMS provides testing of all circuits inside of himself. Also, interface of flight management system includes menu buttons at the top of this flight management system screen, then keyboards with enter button and space, then numbers, enters, then buttons previous and next in different to operate in different menus, because there are probably many pages and we can use previous and next just to change these pages. Then direction to the nearest waypoint or airport. That may be also useful in case of some emergency, if you would like to direction to somewhere. And message button. If you click message button, we will see current messages of flight management system. However, after the initialization of this FMS, we will be inside of initialization menu, and here we can set up current date current time, and identification code of airport where we are. If you would like to change any data, we can use buttons at the left and right side of screen. This is LCD screen, and there are small arrows which point which button we need to push to get possibility to change particular line. And in my case, for example, if I would like to change current date, I just can go to the current date, then go by arrow to this button, then click it here, and cursor, which is yellow here, will be pointed here, and then I can add any date. For example, it will be, okay, 1st of February 2022. Sorry, 2022. We need just to add two last digits. And if we click enter, the data will be approved and system understood that we will use it. Then system proposed me to change current time. Let it change, for example, for 2033. And then if I click enter, I will approve it. And then due to using simulation software, my FMS does not know current location of airplane. If we will be in the real airplane, here we will get latitude and longitude of current position from a GNSS receiver. However, I do not have GNSS receiver because it is computer simulator. That's why I will need to enter waypoint, which will be associated with my location. In our case study, we will use coding of flight plan from O'Hare International Airport, which has ICAO identification code QORD. That's why let's enter identification of airport QORD, and then we will specify our input by clicking enter. Then FMS will check inside of the waypoints database. That's why we've got feedback database waypoint. This is a title of current window, and waypoint chord has been found, and coordinates, latitude and longitude, are the following. Also, optionally, there are following runways which I can specify exactly here. However, I do not want to do it. That's why I just approve that I mean this airport. And we can see that coordinate of this airport has been migrated to my identification. I need just to approve it, clicking enter. And then I will be in company roads. Company roads, it is some database of predefined flight plans from company. And here I can set up first waypoint and probably few following waypoints. And then a particular flight plan will, or particular flight plans will be searched for me from database of flight plans. However, in my simulator, I do not have any company roads. That's why it is clear and I do not have any company roads. In this case, I will go to flight plan directly. That's why here at the top of Honeywell interface, we've got button FPL. It means flight plan. If I click once, I will go to the flight plan list, and you will see that it is totally empty. There is no pre-typed flight plans. That's why it's also not my way. I will click one more time and I will be in the menu of active flight plan. Basically, it is like a loop. If I click one more, I will be in company roles, then in flight plan list, and then in active flight plan. And here I will use active flight plan menu for coding flight plan which I would like to share with you. However, to do it, first of all, let's try to look for real flight plan. In this case, I like flight plan database, and if you type flight plan database.com and then apply search, for example, from Court to Philadelphia International Airport, you can find a set of different flight plans which has been used by pilots and also by gamers for flight between some airports. And in my case, I just choose one of them. Let it be this one. If you remember, flight plan, it is a set of predefined waypoints by which we can fly. Also, I hope everyone remembers that we have ATC roads network, and if you would like to fly from one airport to another airport, you have to take off from airport, then use seat scheme, then go to the set of waypoints which is a part of air traffic service roads, and after that we'll go to start, approach and landing. That's why it is the main idea of flight. And in this case, flight plan includes departure airport identification, and also in international level, ICAO codes usually used. That's why we will take off from Court, then we will go to Bagal waypoint, then to AG, then to Asian, then to Tucson, then to Volan, then to Wheels, and to Philadelphia Airport. In this case, I just would like to visualize this road. I will copy this flight plan from this website. Then I will go to another quite important tool that is may be useful by someone. It is SkyVector, aeronautical charts. And in this case, we've got also flight plan support facility. And here we can specify departure airport. In our case, it is K or D, and we will go to Philadelphia Airport. K, P, oh, it was automatically detected. KPHL, identification code. Then I would like to delete some textual information which is not useful. Then I will click enter, and my flight plan will be detected from SkyVector server, and we've got plotted our flight plan trajectory with all data that we can use. For example, track data, distance between different waypoints in nautical miles, and even if we click into the some waypoints, we can get actual weather data from this airport. That's why this flight plan, it will be our flight plan, which we will try to quote today with our GNS-XLS software. Just a second. Okay, I just would like to change zoom a little bit. Oh, sorry, just a second. Okay, I come back to data which I've got, and now we can continue. Also, why I like SkyVector, because here we've got all meters about current weather of all airports around the globe. Then also we can go to departure, for example, airport, and then here we can find all the schemes for approach, then for departure procedures, and for arrival. And if you would like, we can click, and we've got detailed scheme from AIP. For USA, AIP is open, that's why many resources like that can freely shared with many aviation geeks around the world. Okay, let's quote our flight plan in our GNS-XLS flight management system and look how it looks like. That's why we are in active flight plan menu, and here we can see multiple green stars. And intuitive, everyone understood that we need to change these green stars to our flight plan. And to do that, we can see a arrow which indicates this button. It means that let's press this button to start. Okay, if we click here, it means we need to enter departure airport, and our departure airport, it is Ahara airport. That's why we just type KORD and click enter. The same flight management system will check it in the waypoint database, and yes, I mean exactly this airport. Then I will add Bagel waypoint. It will be my next waypoint. That's why B A G E and L. And then clicking enter. Yes, Bagel waypoint is present in my database of waypoint with the following coordinates, and you see that many years ago it holds NDB. However, I just click enter because it means that I mean exactly this Bagel. Then I will use Ilton, ILTON, and clicking enter. Yes, it is present in USA, and we've got following position, and it is also NDB. Enter, and then go to AD, GEE, E, D, J, double E. We can enter. Yes, I'm in this one. Then Ashen, A, S, H, E, N. Yes, and we can enter. And we've got this waypoint in our database. Then Tucson, according to my flight plan. That's why T U O T Y, sorry, Y S U and N. Enter. Yes, FMS knows this one. Due to limited space in window, FMS will initiate another page for flight plan. That's why here we can see that we are at the second page from 2 pages. And next one, Volan, V-O-L-A-N. Click and enter. Yes, it is present. And finally, wheels. V-I-L-S-S. Enter. Yes. And finally, we will land in Philadelphia International Airport. That's why we just set up KPHL. Just a second. K P H L, and click and enter. Yes, it means airport. We have multiple runways. Yes. And we've got our flight plan inside of our FMS. Then we can use buttons previous and next to scroll between our whole flight plan. Next, we will need to set up departure, arrive, and approach scheme for our flight plan. To do that, we just need to go to departure, and you will see that flight management system will ask us, because we've got a question sign here, do you want to change departure? Yes, we click and enter, we would like, and we will see that for this airport in my database of FMS, I do not have any departures, unfortunately. It is not a problem. I will click FPL and go to arrive. Also, a flight management system will ask me, would you like to change arrive by question sign at the end? And I admitted, yes, I would like. And then flight management system will ask me to set up arrival scheme star. And to do that, we can do 3 options. First of all, we can set up transition point, and all star and runways will be added based on initial added transition point, or point by which we will entering in arrival scheme. If you would like to switch to star, we will see all stars available in Philadelphia Airport. It will be Banks 1, DPN-T4, MAZI 1, VCM 7. That's why now it is not too important. That's why we just need to select some of them. Then for particular star scheme, we can set up transition point. We will see that there are 3 options for transition point, and we can choose one of them. That's why I will choose GVE and click on enter. And we will see that my star scheme includes the following waypoints: GV, OTT, JBO, HG, CANI, theory. And then FMS will ask me, would you like to select it or erase? And of course, yes, we would like to select it because we spent too much time to play with that. And all of these waypoints of star will be added to my flight plan, and we've got 3 pages, and we are at the 3rd page. If we go to previous, we will see that waypoints of star will be like a little bit shifted from the first line. And next, finally, we need to set up approach. We will go to approach, then click in enter, and then FMS ask us to decide what do you think about runways, which one would you like to land, certify runway, why not? Yes, we click in enter. Then FMS will ask me, would you like which type of approach I would like to use, GPS, DME, or NDB. And in case of this runway, only GPS approach is available. However, quite important, keep up to date initial database of your flight management system, because if you keep up to date, it means that you will get all actual data. Sorry, but this training software is out of date totally. It's 20 years old approximately database. I do not want to use it to perform like real flight. I just would like to introduce the basics of flight management system coding, historical flight management system coding, because modern FMS looks like a little bit different than this one. Okay, let's continue. And in this case, I have got only one option. However, probably nowadays there are a few of them. And I will click GPS, enter, and then also I will need to check transition point. I'll back, why not? Just click in one more time, and I will get a few waypoints of approach. And in this case, you will see that here I've got like identification information that I'll back. It is initial just a second. I have it means initial approach fixed, all back point, final approach fixed. Me AP, it is missed approach point because I will use runway 35. That's why runway 35. And in some case, I can use holding pattern BROMI. That's why this abbreviations like specify purpose of these waypoints and what I can do during location in these waypoints. And also the same approach has been created, and FMS will ask us, would you like to select it or erase? And I would like to approve it, and all waypoints with identification like holding pattern has been added to active flight plan. And now I've got a complete flight plan to perform real flight in our flight simulator. And my active flight plan includes 4 pages, and we are at the 4th page. If you go to previous, we will see all the waypoints between Keyord and Kappa HL airport. However, before we will go next and run our simulation, let's make some settings. And first of all, we need to go by each menu in FMS and add missing data. First of all, we've got at the left side button navigation. It means that we need to click nav and we will be in the navigation menu. And here you will see that we will take off from court, and the next waypoint, if you just click enter, it means that we approve that we are in court. And next waypoint will be Bagel. Yes, it is. All distances will be calculated, and then FMS will ask me, would you like to calculate everything in auto mode? Yes, I would like. Also, you will see that in navigation menu we've got 4 pages and we are only in the first one. If you click next, you will see some other parameters. If you will see one more time next, some other parameters and current position. We will talk about it a little bit later when we run simulation. And probably that's all that we need in navigation menu. If you go to vertical navigation menu, here at the first page we do not need to change anything. However, if you go to the next page, you will see that we've got some spaces, and this is not good. It means that we need to enter something. Vertical navigation, it is menu where we have to specify altitude about mean sea level or flight levels for each waypoint of our flight plan, because it will use lateral navigation and vertical navigation. We will need to add altitude of each waypoint. That's why for our trajectory, due to absent seat scheme, I will go to Bagel and I will specify exactly flight level. Let it be 290, and then I will click enter. If I click enter FL 290, it means that if I enter three numbers, FMS will understood that it is flight level number. If I enter 4 numbers or letter G, it means that it will be altitude MSL or about ground level. And then I can specify different values for different waypoints. Okay, first one, maybe I will change also for 2010. Yes, and in this case it will looks like we are during the en-route mode, and all we are getting 210 degrees flight level for our flight plan trajectory. Next, I will go to the next page, and also I need to set up all altitudes for each flight level. Yep. And then we are going into the star scheme, and all altitude levels is already preselected based on input database. That's why we select all flight levels for each waypoint of our flight plan. Then AFIS menu does not operate it because I don't want to play with it because it's something like other information that is not so related to flight management system. Then BRT, it is just brightness. If we hold it, you will see that brightness of screen will be changed. It made for night flight. And if you go to plan menu, you will see that there are some flashing spaces here. In plan menu, we've got we need to enter some input data for mass modeling inside of flight management system. And first of all, we need to set up how many kilos of fuel we have on board. That's why remaining amount of fuel is 0. That's why it's not good. It will not be enough to complete 500 miles flight plan. That's why I will add some fuel. Maybe 2 tons of fuel will be enough. Then also we can specify how many fuel we can reserve for backfly. Here, if you would like, if not, it is not important. Then we can specify fuel flow because it's like a tuning of mass model of airplane, and if it will be real airplane, this data will be connected to a particular airplane. In simulator, we can put any data, and we can see that 2 tons of fuel will be enough for approximately 22 hours of flight. If we will have 85 kilos per hour spending of our fuel. Okay, if you go to the next page, we will see some pre-planned data. However, now we do not have some particular data. Then fuel plan, fuel flow. There are 2 engines by 42 kilos each of them. Then we can specify some data, and I would like to stop at aircraft weight because here we should to specify basic weight. That's why I just specify like maybe 3 ton. Then also I will just a second, enter, and then I will specify payload. 200 kilos, and fuel on board 2000 kilos, and cross weight will be quite valuable, you'll see. And we used only 2 kilos of fuel. Okay, and final, it will be also flight data, and actually now I do not want to touch it because we need to run simulation and then we'll get some data. Then there are only 2 menus here. Let me introduce them. That's why HDG, it is hidden data. Hidden. However, I don't want to. Okay, actually now we've got everything predeparted. You will see that actual hidden it is 106, and according to our flight plan, it should to be 108. It is approximately the same, and we need to think that it is okay and believe for maybe difference in databases. Next, final, it is tune. There are settings for tuning very high frequency radio. This is communication, active radio frequency. If you click next, you will see frequency for navigation facility, DME, TACAN, VOR. We need to, during the flight, FMS will automatically select the closest DME and then tune the frequencies of these DMEs, and here we will see the data. And final, it is airplane transponder identification code and frequency of ADF on board. That's all functions of this flight management system. And now it is time to simulate our flight plan. I would like to go to flight plan. Then I will go to my simulation software and just try to run my simulation. Okay, something happened. Yes, exactly. And now you will see that we will try to take off from Court Airport and go to Bagel Waypoint. And now in our active flight plan, you will see flight levels which will be used. Then here we've got at the left button altitude, and if we can click on it and then clicking back, and we can change it to some other data. Okay, that's why ETE, it is estimated time during the en route. It means that it is the time between waypoint. To fly from Court to Bagel, it will take 22 minutes. Then from Bagel to Ileton, 6 minutes. Then from Ileton to AG, also 3 minutes. Then just a second, if you click one more time, enter, you will see estimated time of arrival. It means when we will be in different waypoints based on current time preselected at the initiated menu of flight management system. And then if you click one more time, we will see distance between waypoints. Okay, next, let's see what we have in our different menus. And also you will see that nowadays we will change our heading in navigation display to the heading which we need to take off. Our track is 108. However, I do not remember which runway on Court Airport we use to take off. Then we can understand actual heading of airplane. Then let's go to each menu separately and let's see what we have. That's why in navigation menu we will see that actually now we are on the road from court to Bagel, and this travel will take the following time. This is estimated time of arrival at these waypoints. The distance is 106, 8, 7, 6, 5, and so on. Estimated time en route 22 minutes and 1 second. Ground speed is 288. Wind is absent. And DTK, it is desired track. That's why nowadays we are in rotating. That's why you can see that we've got multiple angles, pitch, roll, and yaw too. However, we need to get 106 hidden angle. That's why we are in the rotating mode. That's why we are like this one, and we are in the like loop to get the correct direction to get desired track, and then we will go to the horizontal line and continue our flight plan. Okay, next let's check what we have in other page of navigation menu. Here you will see that we do not have any data about wind. Okay, let me check. Here we can see TKE. It is a track error. It means that this track error will be 106 at the end, and it should be 0. And our cross track is approximately 793. This is left and this is right. Okay, and probably that's all. That's why let's see what we have in other screen. Here we can see drift angle. This is angle. If we will have some wind, then we will have a drift angle. This is angle between wind speed and our ground track. It means that it is angle for which airplane will be like moved by wind. That's why drift angle. Okay. VAR. It is magnetic variation angle 1 degree. This is true airspeed 288, hidden angle current, just a second, bearing 106, it should be reached, and our track angle is the same with the hidden angle due to absence of wind. Let's go next. And in the next one, we will see identification, or we will see indication of current latitude and longitude of airplane. Also, we can see that what kind of navigation we will use, and accuracy of this navigation. VPU, it means navigation by navigational aids. And in this case, we just can, like, just a second. We can go to VPU mode, and we will see that we've got position by GPS and we've got position by VPU. And difference between usually positioning by navigational aids and positional by GPS is the following. It's due to error of localization. And if you go to the next one, you will see here that we use a pair of DME for navigation. That's why DME navigation we will use. And also you will see that the following VR DME views. Due to takeoff from Port Airport, we used 2 DME facility. However, for navigation is available some of them. You will see the list of available here. First of all, it is ORT DME, which used frequency 113 and 90 MHz. Range to this DME measured via DME is 5, 4, and so on kilometers. Bearing, it is 23 degrees. And it is stable because probably we are going to the ORT via DME. Then DPA use channel 2. In channel 2, it will be 108.40 megahertz. And okay, now you will see that we do not have possibility to operate with ORT because probably we are under the ORT. That's why we do not have range and bearing data from ORT via DME. And that's why we will use the next one, DPA, and we've got DPA is only DME because we do not have bearing data. That's why range to DPA 21 kilometers. And finally OBK here is, and range is the following. And now we see that we are crossing the ORT via DME, and data from via DME is appeared in our system, and we are going out of VOR. And if we are going to the VOR, now we are going from this ORT VOR. And then if you click next, you also will see that we've got CGT, VOR DME, and with the following data, range, bearing, GOT DME, and EON DME. All of these VOR DMEs or just DMEs can be used in DME localization algorithm. Okay, some of flight management systems, especially military, can use VOR DME, VOR DME, and ADF. However, DME is the most frequently used because only DME positioning method can support modern RNAV, RNP navigation specifications. Also, VOR DME is approved, however, performance of VOR DME is limited only in the small range from this VOR DME ground facility. That's why it may be useful only in the small distances from the ground facility. instead of DME localization methods which support navigation in quite long distances. However, performance mostly depends on geometry of location of ground stations and their airplane. Okay, in this case, I would like to come back to navigation menu, and you will see that what you would like to use, localization by DME or localization by GPS. Okay, let's imagine that we have both of them. We've got two DMEs and we've got two GPS. Actually now we can see current position and position from GPS, and there is a difference between coordinates. However, because we use GPS as current position, that both coordinates is the same and difference is the same. If we click next, we will go to GPS subsection, and here we can get the following information. Okay, first of all, it is HPE. It is horizontal position error, which is equal to 0. GPS time, okay. State, navigation, mode, terminal, altitude aided, no. Rain data is available and is used, and the number of tracked satellites is 8. If you click next, we will see the detailed information about tracked satellites. From previous screen, we can see that we've got 8 satellites visible in current place. And now we can see satellite number, we can see azimuth angle, elevation, signal noise ratio. It means strength of or intensity of signal from this satellite, and health status. It means that everything is good here. That's why I will come back and I will select DME navigation maybe, and left it. Okay, next, if you will go to vertical navigation. In vertical navigation, you will see that we are descending, and we would like to reach Bagel at flight level 210. Just a second, I forget what is it. DN. DN, it is down. Okay, and we can see required feet per minute down 350, and actual feet per minute down is 5050, and you will see that it is quite speedy descending time from the highest flight level. If you go to the next page, you will see actual flight level and all other flight levels. If you click next, we will see all other waypoints with altitudes, even altitude for holding path in for 1040. Okay, next we consider navigation, vertical navigation, and it is time to plan menu. In plan menu, we will see that we've got 631 kilos of fuel. We reserved 122 to come back, and this is our flow. It is a little bit bigger than we have set up because probably we've got some recalculation due to payload on board. And now we've got how many hours we will fly with the following condition. It's only 1 hour and 16 minutes. And range is 345. And if you go to the next, we will see plan parameters. Here we've got ground speed 288, distance, desired track, estimated time during the en route, flight planned data, estimated time of arrival at runway 35, and range of the our satellite is satellite navigation system is available. If you click next, here we will see fuel plan, ground speed, fuel flow. Okay, let's go next. This is fuel flow. Then planned data, date, GMT, takeoff time, flight time. Next, aircraft weight. Okay, it was my fault to set up 2 tons of weight. We need to set up a little bit smaller amount. And finally, okay, we do not have any data because we do not have preselected wind speed. That's why here everything is still like 0. If you go to the heading, you will see we've got our heading 107. Desired track 106 to Bagel waypoint. And if you check tune button, you will see that actual very high frequency radio station is tuned to 118 megahertz. Then if you click next, you will see that current navigation frequency is 108. However, I don't know why here we do not have data from DME navigation menu, because probably it should be copied here. However, probably here we can change it manually, like ORD. Let's check. Okay, it is not available here. That's why it is 0. And XPD and ADF frequencies too. Let's come back to our flight level and we will see where we located and what, okay, just a second, what estimated time of en route before different waypoints. Then I would like to show you also change direct flight. Okay, change our flight to direct flight. If you click this button, you will see that now we are going to Bagel waypoint. However, here we will see our flight plan and we can be vectored to any other waypoint of our flight plan. It means that we are going to by line to any other waypoint of our flight plan. And here we can change the waypoint for which we would like to fly. If you click next, here you will see a set of waypoints, and here's the distance to them and the closest. That's why we can check any approaches in other airports. It used in case if we have emergency situation and we need to land immediately, maybe due to the bad weather forecast. And in this case, we can just go to the closest approach. Then we can select the closest airport and just click and enter, and our navigation equipment will be setting up to travel to another airport. And also, if you click one more time next, we will come back to our waypoints list. Okay, however, I do not want to do it because I've got my flight plan coded. Then I would like to introduce you a little bit about attitude indicator. I think it is quite understandable. Here we've got different scales for pitch roll yaw of airplane location in airspace. In other navigation indicator, there are three basic types of visualization. First of all, it is like a circle where we can see everything that we would like to see, and our airplane is the center, and this blue line, it is our track. However, if we click on a HSI button, you will see that we can change a view of this circle form based on data which we would like to get. Next mode, it is arc mode. In arc mode, we also have three different types of visualization. Relative to airplane, when airplane is always fixed here and all map is rotated around the aircraft, or airplane is fixed in this position, however track is not fixed. That's why it will be rotated within this display. And if we click navigation, here we can see some navigation data. However, it will not indicate it here. Navigation like VOR and D. Okay, probably we have done everything that I would like to show you actually today. That's why you will see that coding of flight management system, it was not a big deal, and probably everyone can use flight plan database and flight planning software like SkyVector to tune flight plan to particular destination airport. And of course, we can easily code our flight plan in flight management system because everything is intuitive and easy to understand. That's why please do not forget about it, and maybe it will be useful for you. Also, this model of FMS is quite old, because nowadays we've got much more welcome flight management system, which has integration with electronic flight instrument system, and we've got much more visualization and much more functions than GNS-XLS. And actually, by this video, I just would like to show you that even historical flight management system can be coded quite simple, and you do not need to spend much more time. That's why thank you for watching me. I was glad to share what I know about flight management system, and I hope it will be useful for you. And thank you for being with me, for watching me, and I hope to see you again, probably in other videos. Okay, bye, take care.